Welcome to lesson 16, problem number 1, where we are graphing exponential functions. Okay, so I just want to remind you that you can email any questions you may have, but for right now, I'm going to take that off of our screen so that I can zoom in and show you a little bit better where these points are on the graph. So just to get started, remember that f of x is basically the same as y. So f of x equals 3 to the x. So we're basically going to substitute -2 in for x, which gives us 3 to the -2, which is 1 over 3 to the +2, which is 1 over 3 squared, which is 1/9. So when x is -2, f of x is 1/9. So I'm going to start by plotting that point, and keep in mind that we're kind of estimating, because when we're at -2 in the x direction, we're right here. We are so close to 0 with 1/9. That is so close to 0, but we can't make it exactly 1/9, so we kind of estimate and sketch it. Okay, -1. When x is -1, we have 3 to the -1 power, which is 1 over 3 to the +1. Let's make that look a little bit more like 1/3. 1/3. Okay, so I'm a little bit further up when x is -1, but still not all the way to +1. Okay, when x is 0, we have 3 to the 0 power. 3 to or anything to the 0 power is just 1. So when x is 0, y is 1. So here is that point. When x is 1, we have 3 to the first, which is 3. And all of a sudden, these points are really kind of growing. So now we have x is 1, y is 3. When x is 2, we have 3 to the second. 3 to the second is 9. So I have to go all the way up here when x is 2, all the way up here to 9, because I know that this graph is in terms like it's 10 at the top. So I'm going to do like a mini sketch of this graph. But again, it's just a sketch. I'm getting infinitely close to 0, but I will never touch 0. Okay, there's our graph. We'll put an arrow there. It just keeps growing. And here it keeps getting infinitely close to 0, but will never quite touch 0. Okay, so now our domain. So our domain is all the possible x values. And in this case, our domain is going to be all real numbers, because x can take on any value at all. So all real numbers is our domain. Our range is going to be that y can be greater than 0. Y will never get to 0. We'll never get a y value of 0 or a negative y. So y is just greater than 0. The asymptote. So if you haven't heard this term before, an asymptote is a line that our graph can get infinitely close to. And in these exponential growth and decay problems, the asymptote is always going to be a horizontal line. In this case, the line is the x-axis, which, as we know, the x-axis is a horizontal line. So it has an equation y equals 0. That's our asymptote, the line that the graph is getting infinitely close to, but will never quite touch. The y-intercept, we already found that when x was 0, y was 1. Okay, so let's go to part B. So for part B, it says circle 1, exponential growth or decay. This is exponential growth because as x is getting bigger, y is growing as well. All right, let's look to the next problem. And I should mention as well that what makes it exponential growth is that the value of the number that is being raised to the x power, the absolute value of that number, in other words, the absolute value of 3 is 3. If the absolute value of the number being raised to x is greater than 1, it's growing because it's going to keep making the y values bigger and bigger and bigger. So that's kind of a hint that in this next problem, we can already tell that the number being raised to the x power, the absolute value of that is still 1/2, and 1/2 to the x power is going to make the numbers smaller and smaller and smaller, because we're going to keep continually multiply by 1/2. But let's see what happens here. And I already know it's exponential decay, but we'll see by the graph what that looks like. All right, so I'm just going to make sure we circle exponential growth. Okay, when x is -2, just to remind you, we have 1/2 to the -2 power and then -4. So I'm just doing all the work for this one value right now. So that's the same as, let's just take the reciprocal, do two steps at once. 1/2 to the negative 2 is the same as 2 to the positive 2 power, because when you raise something to a negative exponent, we can make it a positive exponent by putting the values over the fraction line. So the 1 and the 2 in the 1/2, they switch positions. So we have 2 to the second, which is 4. 4 minus 4 is 0. Okay, if you need a little more explanation on this, please send me an email. Okay, x is -1. When x is -1, I'm going to kind of do that one over here. We basically have 1/2 to the -1 minus 4, which is the same thing as 2 to the positive 1 minus 4, because I flipped that fraction 1/2 and made it 2 and then changed the exponent to a positive. So 2 minus 4 is -2. Okay, 1/2 to the 0 power. We know anything to the 0 is 1, so it's 1 minus 4, which is a -3. 1/2 to the first is 1/2. You can do the work, but for this one, 1/2 minus 4 should be -3.5, and I'm going to write it as a decimal, -3 5/10. Okay, when x is 2, we have 1/2 squared, which is 1/4. So it's 1/4 minus 4, and 1/4 minus 4 is -3 3/4. I'm going to write it as -3 75/100. You can check that on the calculator if you'd like, or do the math, but that is our values. Let's now plot these points. When x is -2, y is 0. Okay, when x is -1, y is -2. When x is 0, y is -3. When x is, let's see, when x is 1, y is -3.5. So we're going to say when x is 1, y is -3.5. And when x is 2, y is just a little bit lower than that, like -3.75. So this graph, because it's going to be an exponential decay, it's only a sketch, but it's going to look like this. Let's try drawing that one more time so it doesn't look quite as much like a squiggly line. Let's try it again. All right, one more time. So we want to go just like this. And this time we are going to get closer and closer to the asymptote down here. So let's start with the domain. The domain is once again all real numbers, because we are going to go all the way to the left and the right. X can be any value at all. The range, on the other hand, I'm going to kind of put this asymptote in here first. The asymptote, the line that graph will never get all the way to, is this blue line, which I'm going to say has an equation, y equals, and notice we're getting infinitely close to -4, but we never quite get there. So that's the asymptote, which also leads us to the range, which means y is greater than -4. Okay, and then the y-intercept was right here. When x was 0, y was all the way down at -3. So notice that this time the graph is decaying. So it's an exponential decay. As x gets bigger, y is getting smaller. But the other thing that happened is this -4 took our graph and made everything go down by 4. And that's why the graph is so low here. The asymptote is now y equals -4 instead of y equals 0. All right, that's everything. Great job. This was a tough one. See you next time.